Imagine being in an exam and facing a question that's not in your syllabus. In real life, you can't just ask for free marks. Similarly, when users interact with AI systems, they often ask questions outside the system's knowledge base. Traditional Retrieval-Augmented Generation RAG systems struggle with these out-of-syllabus queries. That's where Agentic RAG comes in. It recognizes when it doesn't know the answer and takes autonomous actions like searching the web to provide reliable responses. In this video, we'll explore how Agentic RAG, powered by LangGraph, transforms the way AI handles complex, unpredictable questions. Retrieval-Augmented Generation, or RAG, is a powerful approach that combines information retrieval with large language models. Instead of feeding an entire dataset into the model, RAG retrieves the most relevant pieces of information from an external knowledge base in response to a user's query. These snippets are then used to generate accurate, context-aware answers. The effectiveness of a RAG system hinges on two main factors: speed and accuracy. Both are influenced by how data is embedded, indexed, and how the system is architected. Let's see how this works in practice. Traditional RAG systems follow a simple retrieve-then-generate flow. They pull information from a fixed source and answer the question, but they lack adaptability. Agentic RAG, on the other hand, uses autonomous agents that actively decide what to retrieve, how, when, and from which sources, be it a vector, database, or the web. It can plan multi-step searches, adapt queries on the fly, and iteratively refine its answers. This makes Agentic RAG far more flexible and reliable, especially in domains where the right answer might not be in a single database. Traditional RAG systems have several limitations. They perform only single-pass retrieval, missing out on deeper, multi-hop reasoning. Sometimes, they retrieve semantically similar but contextually wrong data, leading to factual errors or hallucinations. They are static and non-adaptive, unable to refine results based on user intent or feedback. Scalability is also an issue, as they're constrained by context windows and computational overhead. These weaknesses make them less suitable for high-stakes domains like healthcare, where accuracy and adaptability are critical. To overcome these challenges, Agentic RAG introduces a dynamic pipeline. A lightweight routing agent chooses among multiple retrieval sources like a Q&A dataset, device manuals, or web search. It checks the relevance of the retrieved context before generating an answer with a language model. This approach not only improves accuracy and flexibility, but also ensures that responses are grounded and reliable, even in complex domains such as healthcare and medical devices. Building an Agentic RAG system requires a robust tech stack. In this project, Python is the core language, with LangGraph and LangChain providing the workflow and orchestration. ChromaDB serves as the vector database for storing and retrieving embeddings. SerperAPI enables web search capabilities, and the OpenAI API powers the language model. This combination allows for flexible, scalable, and intelligent retrieval-augmented generation. Two main datasets are used: a comprehensive medical Q&A dataset and a medical device manual dataset. Both are sampled down to 500 rows for quick iteration. The Q&A dataset combines questions, answers, and types into a single text field, while the device manual dataset merges device name, model, manufacturer, indications, and contraindications. These datasets are then prepared for vector storage, enabling efficient retrieval during the RAG process. ChromaDB is used to create persistent vector stores for both datasets. Think of collections in ChromaDB like tables in a database, one for medical Q&A and one for device manuals. Each collection is populated with combined text fields and relevant metadata. This setup allows the system to quickly retrieve the most relevant documents based on user queries, forming the backbone of the retrieval process. To handle queries that fall outside the knowledge base, the system integrates SerperAPI for web search. This API provides Google search results in real time, allowing the Agentic RAG to fetch up-to-date information when needed. By combining internal datasets with external web search, the system ensures comprehensive coverage and the ability to answer even the most unexpected questions. The traditional RAG workflow is straightforward. The system retrieves relevant documents from the medical Q&A collection, builds a prompt by combining the context with the user's question, and then generates a response using the language model. This process is implemented using LangGraph's state graph, with nodes for retrieval, prompt building, and generation. While effective for in-syllabus questions, this approach struggles with queries outside the dataset. Agentic RAG introduces a more sophisticated workflow. It starts with a router node that decides which source to use, Q and A, device manuals, or web search. Each retrieval node fetches context from its respective source. A relevance checker then evaluates if the retrieved context matches the user's intent. If not, the system can switch to web search, repeating the process up to 3 times. Only when relevant context is found does the system proceed to prompt building and answer generation. This conditional iterative approach ensures more accurate and context-aware responses. Let's see Agentic RAG in action with a medical question. What are the treatments for Kawasaki disease? The router directs the query to the Q&A collection, retrieves relevant context, and the relevance checker confirms it's a match. The system then builds a prompt and generates a concise, accurate answer. This demonstrates how Agentic RAG efficiently handles in-domain queries with high reliability. Now, let's test a device-related query. What are the usage of dialysis machine device? The router identifies this as a device manual question and retrieves context from the device manual collection. The relevance checker validates the context, and the system generates a detailed, context-aware answer. This flexibility is a key advantage of Agentic RAG over traditional systems. What happens when a user asks something completely outside the datasets, like, what's the export duty on medical tablets in India? The router sends the query to web search. The system retrieves up-to-date information from the internet, checks its relevance, and then generates an answer. This ensures that even unexpected or recent questions can be answered accurately, showcasing the true power of Agentic RAG. Agentic RAG shines when handling tricky queries that seem in-domain but aren't covered by the datasets. For example, if a user asks about COVID treatments, the router may first try the Q&A collection. If the relevance checker finds the context lacking, the system automatically switches to web search and tries again. This iterative process, limited to 3 attempts, ensures that the user always gets the most relevant and accurate answer possible. Agentic RAG represents a significant evolution in retrieval-augmented generation. By adding a layer of reasoning and decision-making, it makes retrieval workflows more adaptive and context-aware. Even with lightweight tools and small datasets, you can design a system that intelligently routes queries, validates its own results, and produces grounded, auditable answers. This is a crucial step toward building reliable, real-world AI applications.